Hello, I'm going to show you guys how to work out velocity using progressively average smaller times to work out the average speed. So I have a formula here, so it's y equals 5t squared. So what I want to find, I want to be able to find the average speed, but try to progressively get a more accurate average speed at that time, and then we'll try to work out the speed at that instant. So, well, let's say if t is the number of seconds later. So let's say if t equals 3, so 3 seconds. So at 3 seconds, so if y equals 5, and you put 3 in there and then squared. So 3 squared is 9, so 5 times 9 is 9 times 5, 45. 45 meters. So we travel 45 meters in 3 seconds. But what if, for example, if y equals, so what if t equals 4 seconds there? So then it'll be 5 and then 4 squared. And then so 4 squared is 16, and 16 times 5 is 80 meters. There we go. So if we wanted to work out the average speed between 3 seconds and 4 seconds, you can do this. So if so 80 meters minus 45, which is the time at 3 seconds, divided by, so the difference in the time, so 4 minus 3, which is 1. So it will be 35 divided by 1, which is 35 meters per second. So that's good. But what if we want a more accurate measurement? So if I just get rid of that. Oh. So what if now if I want t equals 3.1 seconds? So I should get a more specific speed here, a more accurate speed. So 5 and then 3.1 squared, and that equals it's 48.05 meters. Now let's do the same process as we did before. So 48.05 minus 45 divided by 3.1 minus 3, and that'll be 3.05 divided by 0.1, which equals 30.5. So now that we have that we can see that, so in that time interval of 0.1 seconds, the average speed is 30.5. So now let's do another interval. let's do 3 point. I can't go that far. Okay, no problem. I've got this. Let's do 3.01 this time. And that's going to equal 45. Where's my cursor? 45.3005 meters. And if we do the same again, so 45.3005 minus 45 divided by 3.01 minus 3. And then what we'll find is this equals 30.05. So as can you see there that we're getting closer and closer to a point the more we decrease the amount of interval. Now let's say instead of t equals 3 point, let's put like a unit there. So let's put like a, where is my oh, it's brushes. So 3 add a diff t, so delta t basically. So it's a some value of t plus 3, and then what we can do is 3 add delta t squared. Now if we expand that, 5, so 9 plus 6 delta t plus delta t squared, and then 5 times 9, 45, add 30 delta t, add delta t 5 delta t squared. And then what we'll do is, so 45, so we'll take that value we just got, we're just doing the same process as before, and then minus 45 divided by 3 plus delta t minus 3. So let's do that now. So simplify that. So 30 delta t add 5 delta t squared divided by delta t. And then let's cancel out the delta t's then. So 30, add 5 delta t. There we go. So do you see though, like where there might be what the answer might be? But what we have to realise though is that delta t, if we want to find the average speed at at that specific point, we can increase delta t to 0. So let's say delta t equals 0, or it approaches 0 more specifically. Zero, like that. So it approaches 0. I'm not going to put it as 0 because I don't think that's correct, because it would cause a, like, if you see here, if delta t is 0 here, so 3 minus 3 is 0, add 0. You can't divide by 0, but you can increase it towards 0 until it's very, very close. And if we do that, it's 30 meters per second. And that's your answer there. So, and this is a good example of the method of increments, which is a way of like differentiating a formula so you can get the average speed or average anything at a specific point. Or it's not called average speed actually, it's called instantaneous speed at that point. So I hope you learned something useful here, and I hope to see you again. Take care. Bye.